All right, hello everybody. Welcome to day one of new learning in algebra class. Today we will be picking up with 5.1. And when we go through these lessons, I will be following a lot, well, not totally following, but for the most part following what the textbook has. So if you want to have your textbook open on like the other half of your screen, you can go ahead, pause this video, open your textbook, and we'll be on page 202. If you don't want to, then that is totally okay. You can just follow along with me here. You will need to have paper and a pencil out. We're going to go through some different terms and things like that, and I don't know if you have to write down all the individual terms. We're going to use them a lot, so they should become very familiar. If you want to write down terms, you absolutely can. But again, you don't have to. What I would encourage you to write down is examples. So as we go through some of these things, I'm going to give an example. I'll show an example, and then I'll pose another question and say, all right, pause the video, solve it for yourself, and then press play when you're ready to check it. And that's where you'll definitely want to be writing things down. And when you're checking, be crossing out what you did wrong, writing in the correct way to do it, and all of that stuff. So if you need to take a second to get a few things ready, go ahead and do that. Otherwise, we will move forward. So today we're looking at, again, 5.1. That is domain and range of a function. Our learning target for this lesson is to find the domain and range of functions from graphs or tables. So just that one learning target, a pretty quick one today. Now, to start talking about domain and range, we really want to look at input and output of something. So the domain, right over here, the domain, or the x value, if we're talking about on a graph, is the set of all inputs. So when we're talking about an input or a domain or the x values, we are talking about all of the same thing. So if we look at our chart right here, we have students to cookies eaten. Our students would be considered our x value in this case, or our input, or our domain. Now, on the other hand, we have what's called the range. And the range is the set of all output values. And you'll see why they're called input and output in a little bit. We'll talk about that a little bit more. But for now, we need to know that when we talk about range, or if we talk about the y values, or if we talk about the output, we're talking about all of the same thing. And we're looking right over here. On our table, that would represent cookies eaten. So typically, when we see these tables, we have the domain on top and the range listed on the bottom. Now, you guys are familiar with how to graph and what XY points look like. So if the domain is our X and the range is our Y, we have our X and our Y, we can make some coordinate points. We have our first one, 1, 2. We have 2, 4, 3, 6, and 4, 8. So now when we list them this way as an ordered pair, we have our domain as each of the x values, our input is each of these x values, and our range, each of these y values. Now at this point, we are not creating a line or anything like that. We are just plotting the points. So if we were to plot these points on a graph, we have 1, 2, 2, 4, 3, 6 would be somewhere up here, and 4, 8 would be even further. So again, at this point, we're not going to draw a line through them and create a line. All we're talking about is those points right there. All right. So let's take a look at this a little bit deeper. Remember, our x is our input, our y is our output, also known as our domain and our range. And a lot of times when we write it, domain and range, you'll just see the D and the R. We won't write out the full words. So if right now we have our input, we don't know what our output is yet, but then you see in this white box, we have y equals negative 3x plus 4. All right, y equals negative 3x plus 4. And this is what we call a function. Okay, a function comes into play when we take our input, we plug each input into our function, and then that gives us the output. Okay, and when it's written in the form y equals negative 3x plus 4, we call that function form. If this was written as y minus 4 equals negative 3x, it would not be in function form. We would have to solve for y to get it into function form. So obviously we would just add 4 to both sides, and we would get y equals negative 3x plus 4. And this, again, would be in function form. But we don't have to worry about solving or getting y on its own or anything like that because it's already in function form for us. On a side note, you will have to get some equations in function form in your homework. So that side note that I just wrote is pretty important to keep in mind. But for now, we have, again, our inputs. We have our function that we're going to put those inputs into, and then we need to find our outputs. So if our first input is negative 2, we want to plug that into, I'm not sure what just happened there, into our function. So then y equals negative 3 times negative 2 plus 4. So we just inputted negative 2. Now our output would be negative 3 times negative 2 is negative 6 plus 4 would be negative 2. Now we put negative 1 as our next input. Y times negative 3 times negative 1 plus 4 gives us an output of 7. Oops, I forgot my equal sign up there. Now if we take our next input, if we take our next input of 0, we have 0, we input it to our function. Okay, and we would do this for each number in our table. So why don't you go ahead and pause the video, find the next 2 outputs. So take 1, the input, our x value 1, put it into our function, find the output, do the same thing for 2, plug it in for x, and find the output. And then after you find those, press play, and you can check your answers. All right, welcome back. Really quickly, the outputs you should have gotten would be 1 if you plug 1 in, you should have gotten an output of 1. If you plug 2 in, you should have gotten an output of negative 2. Okay? Oh. That looks good. So this is what our table would look like. Now, again, we have these inputs or these x values here on top, and we have these outputs or y values here on the bottom. We can put these together to create an ordered pair. So our ordered pairs that we have are negative 2, negative 2, and I'm going to have to go back and forth a little bit. Negative 1, 7, 0, 4, 1, 1, 1, 1, and the last last one is 2, -2. So if we have this table, we write them as ordered pairs. And now if we were asked to graph or put on a graph these points, this input and these outputs, we could do that pretty quickly. -2, oops, don't want to put a dot yet. -2, -2 is right here. Here, I'll get a darker color. Is right there. -1, 1, 2, 3, 5, 7 would be somewhere up here. 0, 4, 1, 1, and 2, -2. Now, we are not connecting these as a line like I talked about a little bit earlier. They're just these individual dots. The last part of this, a lot of questions will ask our domain and our range. So we could find this in a whole lot of ways. Remember, our domain is our x values. Those are x values, and our range is all of our y values. So all we need to do for our domain is we can just look at our x values. So we have -2, -1, 0, 1, and 2. For our range, we'll just look at our y values. -2, 7, 4, 1, and -2 we do not need to list again. So that's all we're doing for our domain and range. And some of the problems, they will just give you the graph here, and you'll have to look at the graph. And if you want to write out all the ordered pairs over here, you can, but you don't have to. But you can just look at the graph, and they'll say, looking at this graph, based on this graph, what are the domain and range? And you can just write in those x values and those y values. Sometimes they might just give you the table, and they'll say, what is the domain and range? And you'll list those values, those x and y values. And then other times, like in this one, you'll have a blank. They'll give you some, they'll give you all the x's. You'll have to find the y's using the function. Okay. So, with that said, now it's your turn. Complete the input-output table for the function y equals 6x plus 2. Then find the domain and range of the function. If we have y equals 6x plus 2, we have our first x value of -1. We have 0. We have -1, 0, 1, and 2. So this would be the time where you pause the video, and I'd want you to fill out the rest of this chart, and then I want you to list the domain and the range. All right, welcome back. Let's check, you can go ahead and check your answer. So if we plug -1 in, we should get a y value of 4. 0 in would give us 2. 1 would give us 8. And 2 into that x spot would give us 14. For finding the domain in the range, our domain would be all the x values, -1, 0, 1, and 2. And the range is all the y values, 4, 2, 8, and 14. So that's a very quick explanation of domain and range. Again, in your homework, you're going to get some more repetition of all of this. But if you get into your homework and you're like, wait a second, what did he say about the function form? And get a little bit confused, feel free to watch the video again, to reach out to me and ask questions. Check out the key and let that be a good reminder and a tool. Don't rely on the key to do your homework for you, because that will bite you big time when the test comes out. but use those resources. And again, feel free to ask any questions when they come up.